All right, guys, so we're gonna continue to work in lesson 3.3, looking at some proofs. So let me present my screen. Oh, is it presenting? Yeah, okay. So here we go. I will demonstrate some of these proofs for you. We're going to be given a piece of information. Make sure you mark that on your diagram, and anything you state as you justify it can be marked on your diagram as well. And then you're going to be proving that lines are parallel. So in order to prove that lines are parallel, keep in mind, how do we prove lines are parallel? We have to show that a pair of corresponding angles are congruent. Or we have to show that a pair of alternate interior angles are congruent. Or we have to show that a pair of same side interior angles are supplementary. Those are the ways of proving that our lines are parallel. Okay, so that's kind of where you're trying to head, and that's probably going to be your last justification for many of these proofs. All right, so let me get my little pen and we'll get started. Always set up statements and reasons. Oh, there we are. So statements, reasons, all right, so our first is always given that angle 3 is sup to angle 5. Now, there's really no way to mark supplementary angles on your diagram. Sometimes I just like to put one angle marker on 3 and 2 angle markers on 5, just as kind of a visual reminder. Oh, let me fix that. Just as a visual reminder that I know information about those two. Or even sometimes I'll make up angle measurements and label them. Like I would say like 100 degrees and 80 degrees. Now, I don't want you to think that those are the actual measurements, because I don't know what the measurements are, but I just wanted to kind of remind myself that they are supplementary. All right, so that's an option as well. All right, we're trying to prove that BD, so I'm going to highlight it in black. BD, I'm trying to prove that this line is parallel to this line. So keep in mind how we prove that lines are parallel. We show that alternate interior angles are supplementary, or alternate exterior angles, or alternate, sorry, I think I said that wrong. We try to prove that same side interior angles are supplementary, alternate interior, alternate exterior, or corresponding angles are congruent. So those are the types of things that we're trying to show here. All right, let me highlight this a little better. I hope you can't hear my kids arguing in the background. If you can, I apologize. All right, so think about how you can pull more information into the diagram. What do you know? All right, you could say that angle 3 is congruent to angle 4 because they're vertical angles. Or you could say that angle 3 and angle 2 are supplementary because they're a linear pair, right? They're adjacent and they form a line. So it's kind of up to you, right? So let's say that angle 3 and angle 2 are supplementary. Angle 3 is supplementary to angle 2. And that's because they're a linear pair. So linear pair postulate. All right. So then from there, where do we go? Okay. Well, if this angle is supplementary to that one, that means that this angle here, if I'm just, again, making up angle measurements, this would be 100 degrees, right? That one's 80. So what do you know about 2 and 5 now? 2 and 5 are congruent, right? Angle 2 is congruent to angle 5. How do you know that angle 2 is congruent to angle 5? When two angles, 2 and 5, are supplementary to the same angle, those two angles are congruent. That's the congruent sup theorem. So now that I know that angle 2 is congruent to angle 5, I can put 2 arcers on angle 2, right? What kind of angles are 2 and 5? They are corresponding angles. And when corresponding angles are congruent, what do you know about the lines? They're parallel. So now you can say that BD is parallel to FE because corresponding angles congruent, that's what 2 and 5 are, implies parallel lines. Okay. Let's jump down to, which one do I want to do? Actually, let's look at number 2. Let me just move it up a little bit so you can see all my given. Okay, so statements and reasons. We'll start with the given that J is parallel to K and that angle 1 is congruent to angle 3. If you want to break your given up, you can. It might flow better if you do, but if you're not comfortable doing that, you don't have to. So I'm going to mark J parallel to K by putting the angle or the arrows. And then I'm going to put an arc on angle 1 and an arc on angle 3 because you're told that they are congruent to each other. Okay? All right. We're trying to prove that the other lines are parallel. So I'm going to highlight them in black just to kind of visually remind myself. All right. Remember, in order to prove that lines are parallel, I'm trying to get a pair of corresponding angles, alternate interior angles, alternate exterior angles congruent, or same side interior angles supplementary. Those are the kinds of things I'm looking for. Okay. All right. So these lines here are parallel. And you were told something about angle 3. So let's bring something else. Let's bring another angle into the picture. All right, so look at one transversal at a time. So maybe scribble this one out or cover it with your hand. Angle 3, what do you know about angle 3 and angle 5? Or angle 3 and angle 4, right? Angle 3 and angle 4 we know are congruent because they are corresponding angles. So I'm going to mark them congruent to each other and write it down. Angle 3 is congruent to angle 4. And you can say parallel lines implies corresponding angles congruent. Okay. Now try to take your given and this statement and come up with another one. All right. Angle 1 is congruent to angle 3 and angle 3 is congruent to angle 4. So what does that mean about 1 and 4? Angle 1 is congruent to angle 4, and that's just by transitive. All right, now that you know 1 is congruent to 4, here is their common transversal. What do you know about the black lines? They have to be parallel because 1 and 4 are corresponding angles. So I know that L is parallel to N because corresponding angles congruent implies parallel lines. All right. Let me scroll down. We're going to look at 1 or 2 more. I want to look at number, I think we're going to look at number 9. Actually, no, let's look at number 8 because that gives us something new. Number 8 and then probably 10. Those are good ones to look at. Statements and reasons. All right. You're told that AB bisects, cuts in half, angle CAD, and you're also told that angle 1 is congruent to angle 2. That's all given information. Oh, I don't know why I wrote a 3 there. Probably because I wrote 1, 2, and then just 3 was the next number in my head. Okay, let's try that again. This is given. All right, so let's mark angle 1 congruent to angle 2 because that's given information. And then let's use the other piece given to come up with another statement. If AB bisects angle CAD, so this yellow angle, there we go, this yellow angle is being cut in half by the black bisector. What does that mean? It means that angle 1 is congruent to angle 3. Okay, so I can write that down. Angle 1 is congruent to angle 3. And how do we know that information? How did I know that 1 was congruent to 3? Because of the bisector, right? So we're using the definition of angle bisector. Okay. Now, if 1 is congruent to 2 and 1 is congruent to 3, what does that mean about angles 2 and 3? You know that angle 2 is congruent to angle 3 by either transitive or substitution. All right. And now that you know that 2 is congruent to 3, what do you know about this line here, AD, and this line here, CB? I'm going to erase this one because that's a little confusing. What do you know about the yellow lines now that you know that the 2 and 3 are congruent to each other? They are alternate interior angles. And when alternate interior angles are congruent, that means your lines are parallel. So you can say that AD is parallel to BC, and that's because alternate interior angles congruent implies parallel lines. Okay. Let's look at number 10. I think that's the one I said, right? Yeah, 10 was the one I mentioned before. Statements, reasons. All right, we're given that angle RQP is congruent to angle, I need to write smaller. Let's try that again. Try to write smaller. Angle RQP is congruent to angle PSR. Okay, so let's mark that first and we'll keep reading. RQP, so this entire angle here, is congruent to PSR, this entire angle here. So they're congruent to each other, all right? Then you're also told that angle SRQ is supplementary to angle PSR. So angle P, where am I? PSR, this red angle that I already marked, is supplementary to angle SRQ. So I'm going to mark that with 2 arcs in yellow. So this angle is supplementary to that one. Well, let's start with that fact. If these 2 angles are supplementary, all right, they share this side in common. This would be the common transversal. So what does that mean about this line here and this line here? same side interior angle supplementary implies parallel lines. So from the first piece of given, which I forgot to write given over here, from the first piece of given, or sorry, this piece of given, second piece of given, you can say that RQ is parallel to SP because same side interior angles sup implies parallel lines. Okay. Then from there, if these lines are parallel, right? And keep in mind what we're trying to prove. We're trying to prove that QP, this line over here, and RS are parallel. Okay, so if these lines are parallel, what else does that mean? Or actually, I just saw something else we could do. Let's look at the two given statements above. I'm finding a faster way to do this problem as I'm staring at it. Do we see that this is the same as this, right? So could I replace the supplementary statement? Instead of it being SRQ is sup to PSR, could it be SRQ is sup to RQP? Could I replace, right? Could I put this in place of that since they're equal? Let's do that. I'm actually seeing a faster way of doing this proof. Let's cross this out. Let's make this, oh, why did I do that when I have an eraser? And this happens sometimes. You might find faster way to do the proof as you're looking at the statements and the diagram. So let's just do a substitution step instead. So I'm going to say that SRQ is sup to angle, instead of PSR, I'm going to replace it with what it's equal to, RQP. And that was simply substitution. All right, so I need to kind of erase some of the stuff I did on the diagram. All right, so again, you started with that yellow angle being, oh, this is going to be a mess. Let me just go back. Okay, so we were told that this angle was equal to this angle that was given, and then you were told that this red one was supplementary to this one. But then using substitution, we were able to say that these two are supplementary as well. That's what my substitution statement just said. So now these two angles, this one and this one, have this common transversal. So what does that mean about this line and that? You can say that they're parallel because when same side interior angles are supplementary, the lines are parallel. So I just took my proof that I was going to do in like 6 steps and made it a 3-step proof. We can say that same side interior angle sup implies parallel lines. All right. All right. Let me come up here. Delete that. All right, guys, that is going to be it for the proofs that I'm going to demonstrate. There's more for you to practice, and I'll see you back here for the next lesson. Bye.